Okay, good morning. I can see we've got enough members to start immediately from 11. Okay, so welcome to our first webinar for this year. So for the first webinar, we'll be looking at the MELSIC IQF GXWorks3 structured text PLC programming language. Okay, so just a background on this language. It's not the most popular language. It falls behind ladder diagrams and function block diagrams in terms of popularity. However, it's still very powerful, very useful, and can be used in conjunction with the above mentioned programming languages. So just the list of the agenda topics to be covered. So we'll have the introduction. Then we're going to look at the structured text statement structure. We're going to have a quick look at the numerical notation. We're also going to have a look at the program execution sequence, some basic concepts in the I/O, the control programs, arithmetic operations, very basic, although can get quite complicated. We're also going to have a look at variable data types, conditional branching, conditional expressions, data handling, and storage. This is a popular one for barcode scanners and so on. Then more complicated operations relative to the above mentioned operations would be the array operations. So the 1D, 2D, and 3D arrays. So we'll have a quick look at that. Looping strategies, data structures, and string handling will also be covered just basically. Okay, so if you look at the structured text PLC programming language, okay, so it's a high-level text-based IEC standard programming language. So for high level, I mean it's more leaning to the text-based, not so much in the visual aspect like sequential flowcharts, ladder diagrams, and function blocks. It's more high level in the sense of instruction list based. Okay. So it's very similar to the C programming language and basic programming languages for computers. So people with that type of background will understand all the concepts here very easily with no difficulty. So by IEC standard, I mean it's the International Electrotechnical Commission standard specifically for PLCs. So for PLCs, there are 5 international programming languages. So the ones we all know would be the ladder diagrams and the function block diagrams. Okay. And there's also the instruction list, as mentioned, and also the sequential flowchart, function chart, as mentioned. We have made a powerful webinar earlier regarding the sequential flowcharts, function charts. For those of you who are interested to have a look at that, it's on our channel as well. Okay, so the structured text, it's very powerful and ideal and practical for mathematical calculations and expressions. Also for string handling, data handling, it's very practical. Although the other languages can do that as well, the structured text is more suitable for that. So each language has its own strengths and weaknesses. So a weakness for structured text programming languages would be the relative difficulty in troubleshooting due to the lack of that visual aspect like you would have for function blocks and ladder diagrams and sequential flowcharts. Another aspect of the structured text is that it can be used in conjunction with the other 4 IEC standard languages. So you don't have to write your PLC program exclusively with structured text, only certain parts of it which you require to. So that's the advantage of the IEC standards of PLC programming languages. Okay, so let's have a look at the structured text statement structures itself. Okay, so there's obviously a syntax to be followed. If the syntax is not followed, you'll get your classical errors in GXWorks 3 and GXWorks 2 for troubleshooting purposes. So you have your instruction command on the left-hand side, and you also have your arguments, which is placed within your brackets, separated by commas. And each instruction statement is ended by a semicolon. This is very important, as this can cause a lot of errors in your program when you compile it, when this is missing. By arguments, that can be variables, it can also be constants, and it can be devices. So for Mitsubishi products, you will probably have your devices here, which is like variable placeholders with addresses linked to it. So obviously you'll have your binary data or your decimal value data and so on being used in the within the arguments of your structured text statement. Okay. So a PLC program consists out of a combination of these statements, which need to be used in conjunction with each other to achieve a certain specific predefined requirement. So we're going to have a look at a few of these basic ones. And then also we're going to have 2 or 3 examples being compiled in GXWorks just to see how to get started, just to get the foundation of this. Okay, so the instruction defines the operation that you want to execute. There's a lot of these, and they are listed in our e-manual viewer in the manuals, which I'll share later on. There's a lot of resources regarding this. Mitsubishi also has a very powerful e-learning website with a lot of materials regarding this, which can be consulted if needed. Okay, so as mentioned, the variables would be the constants, can be devices, or the arguments. Also, you can do nesting. So nesting would be to put structured text statements within the arguments. So obviously with layers of brackets to do nesting, we can have a look at that as well, which is very powerful as well. And yeah, as mentioned, commas important for separation. Right. So if we look at the simple example, if you see on the top left corner, D10, that is a address register which you will find in our MLSec PLCs, which is like a variable storage address. So in this case, we will assign the number 5 to that address register, which can be found in the PLC to be used for calculations or data exchange to an HMI or a SCADA, or to drive a VSD or a servo. That's a couple of the uses you can use it for. So the important takeaway here is that the assignment operator is expressed as follows, with a colon with an equal sign. Okay, so yeah, also important is that the right-hand side value will be written to the left-hand side variable or placeholder. Okay, it's important to have the same data types on both sides assigned in your global variables in GXWorks. If you have different variable types, real to double word or so on, you will either get errors or you will get incorrect values depending on the operation to be used. Another thing is the documentation of your program, very important, known as your labels and comments and statements and all notes. For structured text, you will use the brackets and asterisks to add your notes for each statement. It's quite important for troubleshooting and future expansion purposes. Okay. So as I mentioned, structured text is a high-level PLC programming language. High-level meaning it's closer to the machine language, machine code syntax, whereas function blocks is further away, closer to the high-level range of programming languages. Therefore, your notations needs to be correct and specific for program writing. So here's a couple of prefixes that can be used for your data allocation, the different types of data that will be used. For instance, binary will have a 2 hash in front of your variable because it's a base 2. Octal will be your base 8, and your decimal, obviously your base 10, and then hexadecimal used a lot in our PLCs, modular PLCs, whereas your octal is used more in your compact PLCs, depending on the instruction to be used. So just a couple of examples of how this allocation will work is yeah, your DREG, this can handle any decimal values and also any octal or hex values. So the hexa value 1A has been written to D10 here a constant. So K would be your constant values be written into your D10. So K would be your constant integers, by the way. And then here we'll have an octal value being written to your D10. So that would be the syntax to be used for such numerical notation. Then also very important would be your bit notation. So we do have a lot of PLC courses which these concepts are being described in detail. But just to scratch the surface regarding that. So your bit notation, that would be your true and false conditions, which is numerically represented as a 0 or 1 binary, which is your on and off signals in the field. In real life, which in your engineering value encoding, decoding would be your open and close or your run and stop, etc. So how this assignment will work is exactly the same, except you will use your X for inputs, Y for outputs, N for internal bits. And if you want to use D, that would be a bit to word conversion, which means you will have 16 bits. So you have to address each bit individually. But for basic applications, this should be the syntax to be used for an input or output. Okay. Right. So I just want to move to execution sequence here. So exactly the same as with ladder diagrams and ladder-based PLC programs, you have a execution order that needs to be performed. So it starts at the top left corner, run to the top right corner, all the way to the bottom right corner in that sequence. So that would be your scan cycle in the PLC program. So your scan cycle exists out of a combination of repetitive executions of different program sections. So just visually, these two programs are equivalent. So the execution order would follow as exactly the same. Okay. Not only the execution order, but if you look at the logic here, these programs are equivalent as well. It is easy to see why the ladder is easier for troubleshooting in this case. Okay, because of the, like I said, the low-level PLC programming language, which means it's more visual. So simulation is visualized. Simulation is more accessible and holistic in that sense. So parallel branches will be ORs, serial branches will be ANDs, and so on. So it's very similar in that regard. Okay, so as I mentioned, your arguments that can be used within your instructions, your statements, can be devices. So if you look at this device here, this little program here, it's a typical program which you will see in the basic PLC programming courses which we present as a startup, and then we will obviously expand on that. But so basically, you've got an input, your first input, and your last output on your compact PLCs. So your first input can be like a start button or a on button, and then this can be a lamp or a pump. So it would activate this coil. So this can be written as this in structured text. So meaning that perform this instruction by output the value in your first argument into your second argument. Another way to write this would be this syntax here, because of the assignment operator that's used. So this can also be used effectively, and we will probably use this in the rest of the presentation more than this syntax here, just for simplicity purposes. Right. So here's another example for latching. So ladder latching, it's a standard application in plants for pumps with emergency stops or any this digital discrete output that needs to be latched by a pulse-based push button. So for that, you need to understand the differences between the parallel and your serial effects of your lines. Okay, so if you push the button here, it activates this coil, and which will activate this contact, which would form a path to your output. And then when you break it with the emergency stop, for say, then it will obviously break this line. It would open this contact and open this coil and open this contact. So the same representation is written here with your logical operators. So or means parallel, and means serial, and not will be your normally closed contact. So just a demonstration from that regard, from a digital discrete IO point of view. Right, continuing with the IO control. So there's ways to define variables. Okay, so your label, your global variables needs to be defined for user simplicity purposes and for fault finding purposes, documentation purposes, and so on. In this case, your lamp would be your Y10, your switch 0 would be your input 0, and your switch 1 would be input 1, and switch 2 would be your input 2. So as I mentioned before, each one of these addresses has a different meaning. Like Y should be your coils, your inputs, your outputs, and your X's would be your inputs. So we're going to demonstrate this concept in GFX3 a bit later on. This is just for demonstration purposes, just to indicate that you can use variables instead of devices for your arguments. Obviously, your variable will be tied to the device in your global labels in GFX3. So we're going to have a look at that. Right. So just a simple example of an arithmetic operation being performed. So as I mentioned earlier, your structured text programming language is very powerful in that regard with arithmetic operations. It doesn't take anything away from the other programming languages, but it's more practical depending on the size of the calculation to be performed in structured text. So yeah. This program here shows a totalizer program in ladder diagrams. Okay, so it's a very simple totalizer. It's not like an integrator. It's just to calculate the the tank levels and the product being expelled from the process. So you've got your tank levels, which is added together minus the wasted, and then you get your value. And so this program is equivalent to this program here. The difference here would be this always on, which is a bit in your PLC, an internal special device bit, which is in your PLC that would activate as soon as your PLC goes run mode. But this won't be needed in your structured text. Although it can be used, it won't be needed because as soon as your PLC goes in run mode, it will start the execution cycle as per normal. Okay. Another important concept will be the variable data types. As mentioned, these topics are discussed in detail in the courses, which is a week course per level. So I'm just summarizing it here in this presentation. So obviously you will have your bit types and your integer types. So your integer is a decimal type of data, and another form of another type of decimal type would be your floating values or real values, which would be your values of decimal values next to it. Okay. So as mentioned, when you do an assignment in your structured text, it's very important to have the correct data types for your variables. You will see when you start with your basic programs regarding your structured text in the beginning, you'll have a lot of errors because of incompatible data types being allocated to each other and being assigned to each other. For instance, float to double word and so on, which is in this case an integer. So attention needs to be paid to that. So obviously this is not the extensive list of data types. There's also the string types, which we will cover later on. And there's also the floating point or the real value types that will also be covered. So yeah, it's just the basic introduction regarding that. Okay, so there's a syntax or a representation of variables, a structure that can be used, a notation. Optional, of course, but recommended as a best practice for PLC programming to simplify troubleshooting and program writing and so on. As mentioned, this is a typical error which you'll get when compiling a structured text program, okay, because of values that have different data types. To make life easier in that regard, you can use the Hungarian notation. So it would be the addition of prefixes to your variables, like B for bits, U for unsigned words, W for signed words. So, so as we saw on the previous slide, the difference between these two would be your inclusion of the negative values. So your unsigned word will be your natural values from 0 to 65,000. And obviously your last bit in your word can be used as a signed a sign indication, which means your word, you will only have 15 bits left for your value, and that's the reason why you can only go to 32,000, which is half of that value. So to be W prefix, and then obviously same as your words, you have the double words, 2 to the power of 32 and 2 to the power of 31 for your unsigned and signed W words. Okay. Now, example of this would be your structured text would be written like this. The red would be the notation which we discussed above. Okay? And this would simplify things for troubleshooting. So you can see, okay, that's where the error is from. That's why we're error. So just a best practice, optional, recommended. Okay, so just some basic operations in the PLC. So as I mentioned, we're not going to go into too much depth because that is a field on its own and a set of courses on its own to completely cover this topic from front to back. So, but just to show what's possible and just to give an introduction regarding that, we're going to look at if statements here. So as I mentioned, it's the same syntax as BASIC or C or some other high-level programming languages in computers. Same format will be used. So for your if statements, it's used for conditional branching, your if then. So your conditional expression needs to be met, needs to be satisfied for the execution statement to be executed. Okay, so mathematically that would be your if with two ifs, if and only if statement that's used. If you look at the flow chart, you will not be able to reach your end of statement if your conditional expression is not met. So it needs to be satisfied. Okay. Yeah, just otherwise it will be skipped. The program will skip it to the scan cycle. So it goes again, and oh, okay, it's met, and we'll run through the execution statement. This path is important to understand because you don't want your program to get stuck at the point until conditional expression is met. So it's either running through the execution statement or it's bypassing it. Change this format here. Okay. So example of this would be your if you have a heater and a temperature sensor. So if your heater, if your temperature is below 0, then it will turn on your heater. Okay, so that's a very basic program. Although there's obvious flaw with this program that it will, there's no instruction to turn this heater off again. Okay, so we're going to have a look at more branching strategies. So this is just a demonstration of this concept. Okay, so continuing with that. You have your also your comparators operators. So you've got your comparators, converters, your arithmetic, your logic operators, same as with your function block diagrams as well as your ladder diagram programming, which can be used in conjunction with your sequential function chart languages. So yeah, so it's the classic basic comparison operators that's used, your equal, not equal to, and your greater than and less than operators. Yeah, that's used. So if you have two statements that needs to be executed based on your conditional expression, you can use your if-then statement in conjunction with your else statement, which is added. So you will have three possible outcomes, none of them or either one of these. So if you look at the practical example regarding that, it would be to turn the heater off again when the value is above 0. So that would be one way to do this.
The 6 kilowatt, isn't it 2 kilowatt per element is was 3?
Sorry, someone's mic is still on. Okay, thanks. Okay, so if you look at the flow chart here, you will have your satisfied and non-satisfied statements that would be performed. Just to mention again, there should be another line from the conditional expression to the end of instruction if neither of these statements are met. So just so we can clear that the program won't stop until either one of these are met. Okay, so you can add multiple statements here, depending on how many else's you have, depending on how many states you have in your process. Right. So then we've got the ELSIF statement. Okay, so it's a bit more powerful than the else statement, as this can expand your amount of options in your program to more than just two options. It's a strategy being used for nesting purposes of PLC programming. So for more advanced applications. So an example for that would be to have different outputs based on different temperature ranges. Okay. So here we've got a temperature sensor that will measure the temperature. And you will see that we've got a nested statement inside of a if statement. So it would look at the temperature and give two possible sets. And then obviously your third main set, which is outside of the nesting. So this would be your main branching, and this would be the nested branch within your main branching. So, and this can be done in multiple layers. I think there's a maximum of 7 or 8 layers of nesting that's allowed. But yeah, this is all the specifications regarding these commands are pointed out in the Mitsubishi e-manual details. So each one has its range and requirements and limitations in that regard. Okay. So then you also have your conditional branching, but for integer values. So these are known as your case statements. So not your if and ELSIF, but case statements. So sometimes these can be used as switches in the programming discipline, but in this case, we'll just call it case statements for branching purposes. Sorry, someone's mic is still on there. Okay, perfect. Thank you. Right. So you have your comparison. So if your variable is 1, for instance, then the statement will be performed. If your variable is 2, for instance, your execution statement number 2 will be performed, and so on and so forth. You also have your else statement. So if none of the above, it would be your statement 4. Okay. So in your GXWorks3, when you compile these conditional branching statements and if you use all these case and ELSIF branching, you will have the option to minimize all of this and see the program holistically, or you can expand it and see each process. So that option is there. Right, so if you look at a practical example of a case statement, so if you have a variable that needs to fall into one of 4 categories based on your comparisons, then you will use your case statement. Okay, so you will have your statement 1, 2, 3, and 4, which will represent your categories, your size categories based on your weight being measured. And if you look at how this would be expressed, okay, so this will be the program here, which you will write in pseudocode. So each weight category would be given a numeric value and assigned a numeric value based on the weight that you measured. So this statement, this instruction is used a lot in conjunction with your data handling and also your arrays, which we'll look at in detail a bit later. So this is just for measuring one item at a time and make a decision based on that. Okay, so data handling and storage via arrays. So this is a strong point, a strength of structured text programming, the handling and storage of data. So for the majority of the plants, they will use either your functionality, which is found in your GOTs, or even more popularly in a SCADA. So, but in some applications where SCADA is not available or not used, a PLC does have some form of data handling capacity. This can also be used in conjunction with the SCADA, compile a powerful process. But for the purpose of this, the scope of this presentation will only look from the PLC point of view. Okay, so the data handling by arrays, that's for handling large amounts of data. By handling, I mean reading and writing. So storage would be your writing, reading, handling would be your reading, and so on. So manipulation of data and storage of data within an array. So it's used to sequence and organize your variables. It's the most effective way to do that. So loop processing programs are used to access each one of these cells of these arrays elements to read, write, manipulate, modify, and to handle that. So the most popular ones you will see in a standard PLC program would be your 1D arrays. So that's just a single array. So for instance, a product with multiple colors, for instance, or a single valve with different ranges of flow rates, etc. So that would be your 1D array. You can also define a 2D array. These are known as matrices. Okay, so they've got a two-dimensional data storage to be stored for two variables per data. So these would be rows and columns. An example of that, for instance, would be if you have a calendar and you have got different product production values to be stored in a calendar based on months and days. You see there are two variables there, months and days. You will use a 2D array. If you only have a one-dimensional calendar, for instance, the days of a year or something like that, you'll use a single array, 1, 2, 3, 6, 5 days. Then you get your 3D arrays, more rare than the above two, but still used a lot. So these are called tensors, free-rank tensors. So they are three-dimensional. So they've got rows, columns, and tubes, of course. Okay, so these would be if you have different colors, for instance, for a product, for each day of the year, for each day of the year, with months and days specified. So you have three variables to take into account for the storage of data. So then you'll use a 3D array. Okay. Right. So an example of the above would be if you have productions, different types of production, okay, for different lines, let's say production lines, and you need to know the production number per line or per country, per factory, or so on, in this case, country. You will use an array to store all of them. So it's more efficient for large quantities of variables to be handled. Efficient programming. So you use a single variable to access different variables on a grid, whether a 2D grid or a 3D grid, so on. So, so yeah, we've got different countries with different production rates. Okay, so these are stored in your array called production. Okay, and these values are being accessed or written with an element number in square brackets. So if you, for instance, want to display on a SCADA or HMI the value for country A, the production value, this value will be the one that you would scan to your SCADA or link to your card. Okay, and then this value here, this 0 here, you would change. That would be your user-defined value. So 0 would be country A, 1 would be country B, 2 would be country C, and etc. Okay. So this is a one-dimensional array. But now you get your two-dimensional arrays, same concept apply. The only difference is you've got two elements now. You've got your row element and your column element. So it's always defined rows and columns. Okay. And as you can see, your elements have now two variables in each cell. So not only do you have countries, but now you can also see the color, for instance, of the product being displayed. So a lot of these functionality, most of it, can be replicated via a database handling if you have a SCADA server. So this can be replicated in either side, SCADA or PLC. So yeah, sometimes depending on your process, you don't want the PLC to handle too much of these processes. So then you share the process with a SCADA. Sometimes it's done exclusively in PLC. Sometimes it is done exclusively in a SCADA, depending on the application. Okay, so this is an important concept to understand. So obviously, when you have your third element here, that would be now your tensor, your cube array, or free rank array. So that would be your depth or your tube, as they call it. Value. If you have a third element here, let's say you've got a third variable. So not only the country, but also in the color, but also material, for instance, when you have a third element there. Okay, so each one of these elements is stored in a cell and defined as an array in GXWorks tree, which will be called or accessed using these elements as expressed here. So based on that, you can perform calculations on each variable in each cell. So for instance, let's say you want to add the value 5 to cell 11. Okay, so then you would call that value, that cell value, and you would add your 5 into that same value and store it back into that value. So this would be this cell that's updated from 40 to 45. Just a simple example on how to do that. Right. So as I mentioned, arithmetic operations can be performed, comparative operations, logical operations, and so on. Not only with the cells and variables or the cells of constants, but also with the cells of each other, with other cells. So here we will add all the cells in the third row. So to get your production for the day, for instance, for country C. So that would be an example of how to add all of that together. Right. So to manage and handle these values stored within these array cells, the most efficient way to do that would be to use loop statements. Okay. There are a couple of loop statements. There's the for, while, and repeat statements. So if we look at the for loop statement, we're just going to discuss it very surface level because this is, like I mentioned, an entire course by itself. So so if you, for instance, want to see the production value of your process, your plant, okay, for all of the products being produced for that day, you can write a simple for loop statement to do that. So for this example here, it's not very practical because there's only 3 variables. But if you have 100 countries, for instance, or 100 colors, then obviously to write this program will become less efficient. Okay, so therefore we will use looping, and you will use the following loop, for instance, where you would replace the second element in your array with a variable, and then this variable will increment by 1, and you would accumulate or increment, totalize this reduction today value until you finish your array to get the value. As mentioned, this is just a concept because it doesn't make sense to do it in this example, but if you have hundreds of values, then this would be the most efficient way to do it. Okay. So the previous example, if you want to see all the products being performed, produced by all the colors for country C, you'll use your for loop, and you would just replace this W color, and you run from it from 0 to 2, incrementing by 1, and then obviously when you add these values together, you'll get your 65. So that's just a simple example of how to do that. Right, so another form of efficient programming would be your data structures. So data structures allows you to use a single variable name to represent plenty of variables, okay, by just replacing a part of that variable for more efficient programming. So if you don't use a structure, you're going to have to make a variable for each item in your process. But this is less efficient, so we'll use data structures to do that. Okay, so obviously you have your Hungarian notation. So like S for string, B for bit, U for unsigned word, and then for each line, second line, production line, first production line, second production line, and also your variables which you want to read. For instance, your model, what model is it? Okay, it's a truck. What's the status of it? Oh, it's in production. So this is used in conjunction with batch processing, and also in conjunction with recipes, large recipe applications. And it's a very powerful interfacing tool to be used in conjunction with HMIs, like COTS and SCADAs and so on. And also for databasing purposes. Right. So an example of that would be you will define a structure. Okay, and we will call this structure the first line structure. And inside of your structure, you will have members. So the way you will define a structure is to just add the st prefix in your global variables when you define a variable. So this would be the way to do that. Instead of having a variable for each member, for each line defined, you can use only this type of structure here, and then apply this in your program for more efficient programming. So as I mentioned, structured text programming language is very good with this. It is possible with other languages, but very impractical and complicated, where it's very simplified in structured text programming. So I just want to add another point there regarding that point. You don't have to adapt a structured text PLC program just because you can have to do data handling and data structures. You can just combine a certain aspect of your PLC program in data structures and in structured text. So the certain parts where you need to do arrays or string manipulation or data structures, you can write that in a separate PLC program within your PLC. You can also combine them. The way to combine them would be to derive a user-defined function block and write the function block completely with your structured text and use that in your ladder diagrams or in your function block program as an instance. But okay, that's a topic for a future webinar. Right. So the definition of a data structure, the separation of the variable and the members is done at the dot, typically of data structures. Okay, that's a typical practice in computer science regarding the addressing of variables within members and structures. So, for instance, you can assign a value, a planned quantity of production for the first line by using your assignment instruction in this variable name, in this member name via the dot. So this would be the syntax to be used in that regard. Okay, and this is explained in detail in the email review as well, with plenty of examples. Okay, we're just going to move on from there. Okay, so you can write values in a two-dimensional array as well. So in this case, as I mentioned, an example for a calendar, it's got two variables. It's got your days of your month, and it's got your months of the year. Okay. And then obviously you'll get a combination. Your 21st of July would be your 7 for March 21 in square brackets. To access values, to update values, to read values. And this would be a way to combine your arrays data handling with data structures. So here we've got your data structures where you access your data via your members in your array. So this would be the syntax to be used in such a case where you can display or store values on a database or scalar HMI and so on. Just important to note that in most cases, arrays start with 0. That's a traditional classical point to take into consideration. So this is a custom example of that, where it starts with 1, because you don't have a 0 month. You don't have a 0 day. Okay. So you can also read values. You don't have to write values. So for instance, this would be your planned values, or to read, to write your required products to be performed, to be produced. But you can also read the values that is actually being produced. For instance, a actual quantity, unsigned. So you want to read the values that was produced on the 1st of June, for instance. And then you can read the values, and it will be stored into new past production variable in your global variables. So that's one example of that can be done. Okay, so handling of string data. So this is more practical in terms of applications which we seen in the plants. Barcode scanners to be used. So traditionally, and off the topic here, barcode scanners is most effectively applied and configured and interfaced with MELSIC, IQFX5U, PLC, or any MELSIC PLC in conjunction with a GOT, because of the GOT's inherent functionality for the handling of barcode scanners and its data. However, obviously, you can completely bypass the GOT and use a PLC communication card and to interface with the barcode scanner, barcode reader, and then use your structured text to decode your values being scanned, your string values being scanned in your PLC global variables. So example of this would be if you scan a barcode and you get your a value as follows, where the first 4 characters would be your error code, for example, and then your next 8 would be the date of the error code being read. So this blue part here would be performed by your structured text program, which you will write, okay, with different commands and string character manipulation and so on, which would be, as mentioned, easier to handle with the GOT, but not a prerequisite. So if we look at this example here, okay, when you assign a value, a string value to a variable in GXWorks3, you need to take into account the different types of strings being used. So if you look at the Hungarian notation again, your classical ASCII characters, alphanumeric characters, would have a S prefix, okay? And then if you have strings or characters from different languages, for example, okay, you'll have a WS a prefix for your Hungarian notation, which is a wide string. Okay, so it will always depend on application and your device being connected to it. So in this case, when you scan a standard string, which would be in 90% of the cases, you'll just have a single S as a prefix to your variable in a PLC. Okay, so another point that to take into account of a string is that your string value will need to be enclosed by a single-ended quotations. Okay, so just keep that in mind there. So if you want to decode a string being read from your barcode scanner in this application, and you see in the manual of that product that the first four characters will indicate the error code, for instance, you will only need to isolate the first four characters to identify the error code from your string. Okay, and you want it to be stored as an error code, for instance. Let's say you want to display an error code on a production line or for a daily report of all the errors that you received, etc. Then you would use a program instruction statement as follows, for example. So you, on the left of your string, the first four left characters, okay, of your string variable being scanned, okay. This value can obviously be updated by the number of characters that you want to read. Let's say you want to read the first two characters, that would be 2. And then when you do that, you will extract the error code and store the error code in this variable. So that's one example to do that. Sometimes you only want to read the date part separately and store them in a separate variable. So for that, you will use a MID instruction. Okay, so the MID basically defines a starting position of your string and the amount of characters to be extracted and stored in your string variable. So in this case, we would start at ASCII character number 6, because this comma takes a character as well. And we want to read these 8 values, characters, ASCII characters, and store it into the date variable. We will use this syntax here with this instruction, MID instruction. So just an example of how to manipulate string data with barcode scanners or any string data with structured text. Right, so we're going to have a look at a couple of practical examples. I'll just how to start your own little structured text PLC program in GXWorks3. So it's just 3 basic examples. Obviously, for more in-depth examples, that would require a more in-depth course. But yeah, so what we will do is we're just gonna open GXWorks. I'm just gonna start it from the start. Yeah, just close this program. So what I'll do is we'll start a new program. So obviously you have all of your IEC standard PLC program options which you can use. So in this case, we'll use a structured text. And so now, as with all the other programming languages used, you have your programming area. So this will be your programming area, and the subsection of your program will be found in main here. So we might as well rename that. We call it Pythagoras, which we can do now. Another important element or factor to consider is if you're using variables, and more importantly, if you use variables in conjunction with devices, you're going to have to assign a label. So if the label doesn't have a device, so you're not going to scan something to a SCADA or write something to a VFD or display it on the card, then you can just use your local variables. You can call all your local variables here for internal use for this program body only. However, if it's an item that will be used externally, like I said, SCADA, GOTs, VFDs, or servers, or whatever the application may be, another PLC, for instance, then you're going to have to use a global variable, because this will allow you to assign a register to each variable. Also optional, but you can assign it. So if we look at the task here, just to calculate the Pythagoras theorem here. So we have three variables, C, B, and A. So if we're gonna create that program, we're gonna have three variables which we'll need to define here. Just a reminder, this is not a PLC programming webinar. This is just to demonstrate the concept of strings. So we're not going to go into too much depth. Just want to show the concept. So we'll create the variables. Each side. Okay, just want to create so it will be floating values. For reals, because we are going to we are going to calculate the decimal points as well. Hence why we use reals there. So if you need to assign a register to this, let's say you read two sides of this triangle from a plant, from a product, operating plant, and you're going to display one output, then you're going to have addresses assigned to it. Okay, so obviously we won't use X, Y, or M. We use D registers because these are words, and floats takes 32 bits, so I'm not going to use consecutive words. Consecutive devices, just to handle both the entire real value decimal values. You can also use retentive registers. Just a side note there for this purpose, this demonstration. Yeah. Okay. Right. So now we can write the program. You will call the value which you defined. So if this value is black in color, okay, then it means you didn't define the variable. It needs to be defined. You're going to get an error when you compile your program. So it needs to be pink. And then also the program needs to be written front of the semicolon, yeah, just to prevent any errors there. So I'm going to calculate the C value, of course. and that value will be assigned to the output or the conclusion of this formula here. So, square root. So that would be a square root function, which will be contained within brackets. And inside of that brackets, we will define the variables, which will also be contained within brackets. Just make sure that each opening bracket has got a closing bracket. So value 2, which is a real value, and we want to raise that to the power of 2.0, because we are multiplying with floating real point values. Same with the other side. Okay. So I was just going to compile that, see if there's any errors there. To check everything, the syntax and everything else. You see, okay, so sees that these values are used on the global. So you know, don't want to use those ones. Let's make it 200. So we said it must be matched. So let's keep it matched. Okay. Right, so we've got 0 errors here. The next step would be obviously to write this to a PLC. I'm not going to use a PLC, I'm just going to use the simulator. Okay, so the moment the PLC is in run mode, you obviously can see your program. You can see the values being stored in each of these pink variables here. And you can also use this in conjunction with your watch window if you want to add values. So what I'm going to do is I'm just going to highlight all of this and register it into a watch window for simulation purposes. And we also like to register yes, let's see as well. So we can, let's say, the user in the plant, there's following values in that formula for a product to be produced, or whatever the case may be. The calculations being performed and stored in C. Okay, so as I said, nothing special about this. It's just to demonstrate the concept. This entire program can be stored in a function block if you create your own function block as well, to only do a certain part of your PLC program in structured text, and the rest you want to do in function blocks or ladder diagrams or so on. Okay, so that would be the first example. Yeah. Okay, so if you look at another quick example, for instance, if you want to use ELSIF to give you different outputs for a value based on a bit, for instance, based on a bit and based on a input value, a decimal value. Then you have your ELSIF. So we will use this type of syntax here. So if you look at the example here, you've got a word value of 1, and you can have a 0, 1, 2, or 3, or anything else as that value, and it will work in conjunction with a bit flag. Okay, and then what it will do is it would control your value 0, so your value 1, based on your value 0, based on decimal values. So if your value 0 is between 100 and 200, then you have a 1 stored in your p value 1. In this case, it would be this instruction being performed, this execution instruction. So this part here between the ELSIF and then would be your conditional instruction, that one as well. Okay, so if we execute this in a PLC program, Right. So you can either start a new program if you wish, or you can just add a new data. I'm going to call this one else if. So then you will run both PLC programs. And this will be a structured text. And we will obviously need to create those variables for each one of those values. So we go to global, and we have a b value 1. That was a word, say signed word. And we have a v value 0 as well. Also a signed word. I'm not going to add devices in this case, but you can. Difference. And also we add a B flag, which would be the bit to activate this process. So it will be a bit type. So I think these are the 3 variables being used. Yeah. We're going to write this program. Yeah. So if statement. Just remember to write in front of the semicolon there. So if your if statement, if your B flag is off, so it'll be a not. Just notice the blue color here. So the blue means it's a function. And if it's green, it's a function block. Usually user-defined, but it can be both. It's not exclusive. So the blues will be your functions traditionally shipped with your JXWorks package. That's all. So it will be your B flag 0. So if this is off, then your B value will be assigned a value 0. Else if. Now we have a comparator and the logical function combined with this ELSIF. Just want to see ELSIF is without it must be blue. Your functions must be your instruction must be blue. If it's black, it's a illegal instruction. You'll get an error. Okay. So ELSIF b value 1 and 0. It's 0 or so there's another logical function there. It's 200. Then b value 1 must be assigned a value 1. ELSIF, so that's another branch. If your p value 0 is less than or equal to 0, so that would be less than or equal to 0. And so both conditions must be met. Or p value 0 is smaller or equal to -9. then your v value, your word value 1 will be 2. And then anything else outside the scope of those branching, your v value 1 will be just going to end it. Don't forget the semicolon there. Okay, let's see if this works. So as I mentioned in a presentation, that if you have many of these structured data, you can expand or minimize it if you want to skip a part of that. So I'm just going to compile, see if there's any error. So just open Outlook window. No errors, no warnings. So this seems legit. Let's test it. So I'm just gonna write this program to my simulator. Okay, and I'm just gonna add all of these values to my watch window, just so you have all the variables here. And then what I want to do is I just want to monitor the outputs. So it would be your monitor command. So we see everything is 0 right here now. So if we turn this bit on, you'll see that your value 1 is activated. This last branch is activated. It's a 3 there. And now obviously you can add values to your value 0. So if I'm going to add 20 there, you'll get different values here. If you're going to get 100 there, you can get different values here. So just a small example of division branching. Right, last example, just to demonstrate arrays. This is a very short one. So the purpose of this one is, because this is a question we get a lot, is to demonstrate how arrays are actually being compiled in your global variables. So if we just open JSWorks again, so just want to see the variables which we had there. Okay, so we've got the word array 1, word array 2, which is a 2-dimensional array. Just want to make sure we add those as well. Okay. Right. Always a good idea to start with global labels, which would follow from your best practices when you do your SCADA projects, you know, your IO lists and so on, your IO list data types to be scanned to your SCADA, is to first create your global variables and then write your program. Although JSWorks 3, it's, you can dynamically create variables as you go with the program as well, if you are short in time. But yeah, so we've got two variables. We've got a word array 1, which is a 1-dimensional array. Okay, so to assign an array, you have to tick this box here, and then obviously you can add how many variables your array has, your 1-dimensional array. So this is a 4 by 0 array. So it's just a row. If you have a matrix, you can add second-dimensional arrays, and if you have a tensor, you can add a third-dimensional array as well. Okay, and each array can have different types of data types. So in this case, we'll have a unsigned word. So that would be our single-dimensional array, and also have a matrix. So this will also be a data type of unsigned, but it will be array. I'm just gonna add Let's make a 3 by 3 matrix, for instance. Okay, so that's how you will define the array. So if you recall how to access the elements which is stored in the cells of an array, you will use square brackets. So I'm just going to make a new program here. This one will also be structured text. Right. So in that example, we just want to store a value in an element in an array. So we can use array 0, and we want to use the very first cell in that array. Okay. And we want to store a value into it. So it would be the assignment operator. And whatever value you want to put into it, as long as it falls under the unsigned word. So obviously you can't put a floating value there, you get an error. And in this case, we'll also add a comment, which is written in 2 asterisks, which is stored in 2 brackets. So I'm just going to call this one-dimensional array assignment. Okay. But we also have a matrix. And we want to just let's see. Sorry, we don't have the W. Okay, we'll do one day matrix. So make sure we're using. Oh, so nice. Array. Array 1. This would be array 1 as well. And then whatever is stored in your matrix array in this cell, for instance. So you'll have your first row, second column must be stored into your array second cell. Okay, all looks good. Semicolons in place. Let's just see if there's any surprises. Okay, there are no surprises yet. And we're just gonna write this program to the simulator. The shortcut to this is I'm just gonna stop the simulator and then start a simulator again. We automatically write all the programs into the simulator. Okay, and it's simulating is working, the monitoring is working here. And if we add these values to our watch window, we can, okay, so if see so that one, we also want to add that one. Yes, and then this one. Okay, so we see that in the first cell of this array, there's a value 10, because we assigned the value 10 there. And obviously you can't change this value because it's overwritten by the program. So that value will always be 10 unless this value is changed. And the second line of this program, the second statement, we will have to put a value in this cell of this matrix. So if I put in 35, for instance, then we see that 35 has moved into the second cell of this array, and 35 is stored there. You can also see it here. So this is just a simple demonstration of arrays and matrices in structured text. Right, just the list of abbreviations and acronyms and nomenclature that we used in this presentation. So we will also add this in a knowledge-based article for those who want to have access to this information. All of this information can be accessed by these resources. I'm going to throw some resources in the chat now as well for download, including examples and manuals and references. So from the e-learning, I'm just going to throw it in there. Chat, if I can attach it. Doesn't allow me to attach that. I think the file is too big, but these are the sites that you can access this information from. I will also create, like I said, a knowledge-based article with these links and also the examples for each one of the programs we discussed in this presentation, just for sample purposes. Right. Do you have any questions? Okay, let me just check in the chat. Okay, for Marcin, yes, there will be more of these webinars. We plan to have at least one a month. The next one will be, I think, 22nd of March. Tanya and Samantha will keep you guys updated. I think the next one will be about PID control. So we'll cover that concept basically. Class, yes, okay. So I will compile an example of pointers, how to use that. And then what I'll do is I will put the knowledge-based article, send it through. If you guys want me to send all these links and materials, can you also just put your email addresses in the chat so I can just send you guys all the samples and examples? So at last, yes, I will definitely give you an example of a pointer. How to use a pointer inside of the, I'm assuming to point in an array. So we will do that. Perfect. Okay. Any other questions? Okay. I think that is all for this presentation. So if you have questions or if you require additional information or resources or anything, you can just contact me on this email, yeah? And I will get back to you soonest. Okay.